Okay, great. See, our number is steadily rising, so I will get started for the sake of time. So good morning, everyone, and welcome to the Symposium AI at Dawson College Revisited. My name is Hilary Sweetman, and I'm a PhD student at McGill, and I will be the chair for today's session. So I'm just going to start off with a couple of administrative announcements. So you'll notice at the bottom of your screen that we're enabling live transcripts to accommodate people who prefer to have captions on. If these are bothering you or you prefer to have them turned off, you can do so by clicking the more button, so the little dot, and there you can toggle them on and off at any point in time. So please feel free to do that. And also just to let you know, this session is being recorded. So if you're not comfortable having your camera on, that's totally fine. Feel free to turn your camera off. And you can also rename yourself if you prefer to remain completely anonymous. So today we will hear from a long list of speakers, which is excellent, and we will have a Q&A session at the end. So I don't want to take up any extra time with my introduction, but looking forward to hearing from our speakers, and I will pass it off now.
Myriam, you can share now. We'll start. Hi, everyone. Welcome again to this symposium. This is an update on the progress of the Dawson AI Artificial Intelligence Initiative announced at SALTISE 2019, 2 years ago. My name is Trudeau, and I'm here today presenting with my fantastic, dedicated colleagues from the Dawson AI steering group and AI-themed teaching and research communities of practice. Today, we will present on the mandate given by the Dawson College Board of Governors in the context of a comprehensive 3-year plan, what was promised, where we are now, and the road ahead. Special focus will be given to the dimensions of the initiative that contribute most significantly to capacity building for the delivery of high quality, relevant educational experiences that incorporate AI competencies and the development of digital literacy across programs. Over the last 2+ years, significant contributions have been made from many faculty members with interest and participation growing across all sectors of the college. We are pleased to have an exemplary fellow of the AI-themed teaching community of practice, Vanessa Gordon, with us to share her experience. Our main goal today, though, is to bring awareness to the AI initiatives at Dawson and to leave space for discussion, and also to invite collaboration with the SALTISE community. First, a quick look back at the steps taken by Dawson AI since we last presented here. The original mandate that led to the 3-year plan highlighted in general terms the need for exploration of AI opportunities in and out of the classroom. This was broadly interpreted and taken on as an ambitious plan for a comprehensive approach to AI education. At the SALTISE conference in June 2019, where several AI education talks were given, including a major plenary panel, Richard Filion, our recently retired Director General, to a large media fanfare that made headlines across the province, announced the launch of this comprehensive artificial intelligence initiative as the largest investment in an AI project by CEGEP. Adding to the weight was the announcement of an extensive AI advisory board comprised of research scholars, business leaders, and other stakeholders from the Montreal AI ecosystem. Since the launch, we have met twice with the AI advisory board, consulting on the goals and direction of the initiative. We have collected expert advice on the skills needed for technology and career programs, pre-university programs, and for retraining opportunities. We've also taken a deeper dive into the AI competencies relevant for academic and industry workforce paths that college students may follow. Pandemic restrictions and associated constraints obviously have altered our projected meeting schedule as well as our priorities for development, yet we remain on track to realize the central goals of the 3-year plan. A structure for good governance and effective collaborations positions us well to address the themes of the plan, which are to initiate and implement strategies for curriculum development, college level research program, training or retraining opportunities through continuing education and our Center for Training and Development, as well as outreach activities that engage and inform the Dawson community. These themes are supplemented by the use and development of tools for an institutional AI strategy and the piloting of certifications. The focus on curriculum development and research, which you will hear more about, highlights progress over the last 2 years and is central to the core strategy of capacity building within Dawson with the goal of financing and sustaining the initiative as it evolves for the long term. We wish, however, to highlight progress through activities related to curriculum development and research across a range of programs with a growing number of faculty being integrated through 2 distinct AI-themed communities of practice. This is the foundation for success as a college-wide initiative for the next phase of work. I'll pass now to my colleague from the Humanities Department, Carl Saucier-Bouffard, coordinator of the AI-themed teaching community of practice for the last 2 years and a driving force behind many AI initiatives at Dawson. Carl, over to you.
Thank you, Joel. So as Joel just mentioned, I've served as a coordinator of Dawson's AI-themed teaching community of practice. And as you'll see in my presentation today, I do put emphasis on the word teaching because, as briefly mentioned by Joel, there are really 2 different, distinct AI-themed communities of practice at Dawson College with different mandates. And we're going to talk about the mandates of both throughout this presentation. Next slide, please. So let me just explain very briefly this distinction right now. So as you can see on the slide, there is a steering committee and Joel has been coordinating this steering committee, and the presenters today are essentially all members with one exception of the steering committee. But then in order to achieve the goals and the mission outlined by Joel, one of the main components of this 3-year AI plan at Dawson College was precisely the creation of 2 distinct AI-themed community of practice, which you see right now. So the one that you see in the middle is the one that focuses on developing teaching modules on AI. So hence the teaching community of practice, and that's the one for which I've served as coordinator these past 2 years. The one that you see on the right of your screen is the research community of practice, which focuses on applied research in AI, of course. And this is the community of practice that was coordinated by Robert Stevens this year. So he's going to expand on it during his section of our presentation. And I see that most of you guys are not part of Dawson College, or you're not Dawson College teachers. So let me just briefly clarify what a community of practice is. Most Dawson College teachers would be familiar with this concept because really there's a fair number of them at Dawson. But I realized that it's not the case in every single Montreal institution. So every single team of practice would have their own coordinator and their own mandates as well. You may have heard of Dawson's active learning team of practice, which has been very involved in the previous editions of SALTISE, but we'll also have the e-learning team of practice, the writings and the disciplines team of practice, and so on, in addition to the 2 AI-themed ones that I've just mentioned. And all of them essentially consist of a small group of teachers. Usually it's between 3 and 10, so relatively small, but who come from multiple departments. So they're all multidisciplinary in nature, and they motivate and support each other as they work to improve at least one aspect of their teaching. Next slide, please. Thank you. So the fellows of each community practice, including ours, would meet regularly to update each other on the progress made, to share readings, evidence-based practices to improve the teaching, and they also collaborate on many different projects and events, and I will give you guys specific examples of such projects in a few minutes. And by the way, if ever you're interested in learning more about Dawson's communities of practice, if you're a Dawson College teacher, you might want to join one of them at some point, or if you're not a Dawson College teacher, you might want to start one. in your own institution, well, in that case, you may want to attend tomorrow's symposium entitled Communities of Practice Everywhere, which will start at 9:30 a.m. So a small plug for Chris Whitaker's symposium tomorrow. Next slide, please. Yes, thank you. Now, in the case of the AI team teaching community of practice, fellows are expected to develop teaching modules. And I'll give you examples of that in a moment, but teaching modules, in some cases, even entire courses on the ways in which AI will likely impact the respective field. So that's really the mission. So the develop teaching modules on the ways in which AI will likely impact the respective field, which could be mathematics, applied ethics, physics, 3D animation, and so on, not only computer science, right? In fact, our fellows in the past 2 years have come from 8 different departments so far. So more precisely, there were 7 fellows in the first cohort of our community of practice. So that is the 2019-2020 cohort. And you get to see all of their names right now on the screen. And the teaching modules that this first cohort developed during their fellowship are available for all to see and use on the Dawson AI website, which you see at the moment. And for the 2020-2021 academic year, so for this academic year, 8 other teachers were recruited to be part of this community of practice. 5 of them have already completed and published their portfolio on this website. So if you'd like to have a look at any of these 12 published portfolios so far and teaching modules, again, take note that they can be found on the Dawson AI website, easy to find. I mean, www.dawson.ai. And all teachers, by the way, not only Dawson College teachers, are encouraged to use any of the teaching material shared on this website. It's really open source teaching material, so to speak. Next slide, please. So this gives you an idea of really a small part of one of the 12 portfolios that I've just mentioned so far, but just so that you get a better sense of the kinds of files that are being created and published by our fellows. Portfolios typically include slide decks. You get to see one example here. Assignments, instructions for active learning activities. There's a fair amount of them. So if you're looking for active learning activities on different topics related to AI, you'd be able to find some of those on our website. Reading recommendations, as you can see, video recommendations, and so on. So that's what we mean by teaching modules. So especially the slide decks might be useful to some of you guys. And through these recently developed teaching modules, so far, again, 12 are being published, but 15 in total will be published in 2 weeks from now. I roughly estimate that we managed to reach at least 2,000 Dawson College students who had an opportunity really to learn about one or more aspects of AI as part of at least one of the courses at Dawson. Now, on this note, so that you have a better idea of the kind of teaching material and content developed by AI teaching fellows, I will now give the floor to Vanessa Gordon, who was one of the AI teaching fellows this year. So Vanessa, please.
Thank you, Carl. I think we can flip the slide. Okay, so I came across, well, I participate in the AI community, not as someone initially interested in AI, but as someone who teaches political science and is preoccupied with climate change. And I was just looking for a way to help students find agency when facing this issue. So it's a very solutions-based approach. Next slide. And my thinking sort of developed out of something that actually was published in 2011 by American political scientist Erica Chenoweth. She made waves when she used big data to come up with a conclusion that nonviolent protest is more likely to achieve results than armed resistance, as long as 3.5% of the population of a political territory were engaged. From an academic standpoint, earlier in my career, I had been exposed to data in the service of early warning systems for social conflict, and it had its issues. But this is an entirely different context. And what was really interesting about this research is, you can flip the slide. Yeah, it was adopted. Erica Chenoweth's research has been explicitly adopted by much of the climate activist movement. There is consensus within the movement that broad-based mobilization for transition is the way out of the climate crisis. Next. So this publication, as well as Rahul Bhargava's Data Storytelling Studio for the Climate Movement course at MIT, which all his stuff is available online, and it's absolutely fascinating. It inspired me to see if I could devise a way to empower students to use data to communicate to the public in the service of broad-based mobilization for transition. Next slide. So at this point, I'm sure some of you are like, okay, so tell me where the artificial intelligence comes in. And in the course of my fellowship, I had the privilege of attending Forward 50, which is a conference that brings together government and technology execs to work together on finding ways to use technology to make a better society for all. I can't emphasize how fascinating this conference was. There were just a gazillion speakers. There was so much happening, and I learned so much. And for one thing, I learned how data science, deep learning, neural networks, machine learning, and finally artificial intelligence relate to one another, which is a huge thing that I learned. I'm sure that this image can no doubt spark debate in the audience. But for the purposes of now, I made this handy graph to situate this class in relation to artificial intelligence. It shows that this class can be a good starting point for students who might later on choose to move on to deep learning, machine learning, and AI. Next. So how? Students in the social sciences need to start with data literacy. The pedagogical approach that I use is an active learning approach that uses focused, guided, engaging, and highly expandable tools to get students to visualize and communicate data. And in this, I'm heavily borrowing from Rahul Bhargava. Next. I guess that's the next slide. Okay, so students learn to read data, they learn to work with data, analyze data, and argue with data. And I had to adapt the studio course to COVID conditions, which was intense, but I made a platform, and here are the course modules. Next. Here we go, there's the platform. I used WordPress LearnDash. And so here you see the different modules. So it starts with finding and telling stories with data, and then ethics, then getting and cleaning data, analyzing data, telling a story, and the end part is the storytelling studio, where students actually combine the technical part with the artistic part. Next. I'm not going to go through all the modules, but here's an example of getting and cleaning data. It includes lecture, audiovisual materials, and activities on how to find data, scrape data, store it, and clean it. It ends with a highly amusing presentation on the kinds of things that happen when you don't clean data properly. A lot of bad things happen, and a lot of money is lost. It's amazing. The main activities for students here include coming up with research questions and learning to find relevant data sets for a number of sources, from a number of sources. They also use Hadley Wickham's work on tidy data to clean an assortment of samples from some very awful data sets. Next. So the actual studio component of the course at the end engages students to create a number of data presentations using data from the city of Montreal. So here's one from this semester, a time-lapse data map that tracks the construction of housing co-ops in Montreal. Next. So this is actually a really nice one that I like, that sort of conveys green spaces across different boroughs of Montreal. I like the abstract art idea. Next. As of this writing, my students are currently struggling through making data sculptures to honor Montreal's snow riders, winter cyclists on bike paths. The data was collected via 48 bike counters dispersed across the island. And I like this clever and simple Allen key flat sculpture that conveys the number of cyclists at 6 locations during the busiest 15 minutes of the winter. So that's it, my course in a nutshell. Thank you for listening. I'm done.
Okay, so I'll jump in here. So my name's Robert Stevens. I'm a teacher in the Humanities and Philosophy departments at Dawson. And this year I've been the coordinator of the AI research community of practice. So again, just to separate the research and teaching, the teaching community of practice are teachers at Dawson, fellows who are developing portfolios of AI themed work to do with students in the classroom. The research fellows are also all teachers at Dawson, but the focus of the community of practice is on research that they're doing, mostly outside of the classroom, but as we'll see, there are a lot of leaks into the classroom and working with students along the way, even as part of the research community of practice. So we had 4 fellows in the community of practice this first year. So if you could go to the next slide, Myriam, we'll quickly go through the mandates. So similar to the teaching community of practice, when we take on fellows, we have some mandates for them. The first one is like the teaching community of practice, the research community of practice meets. We met every few weeks during the course of the term. Of course, we had to do it online, but the idea was to have an interdisciplinary conversation about research that everyone's doing individually and get some feedback and discussion. Very fruitful discussions because they were extremely interdisciplinary. Of the 4 researchers in the community of practice this past term, we covered all the sectors of the college. So we had computer science, we had cinema and communications, and we had sociology. So we're in all 3 sectors of the college. So we had really great interdisciplinary conversations about research. So that's the first mandate, is just to take part in that community of practice, which was extremely engaging and fruitful. The second mandate is similar again to the teaching community of practice. We're asking that the fellows disseminate the ideas that came up during the community of practice and give some talks in other venues, both within and possibly outside of Dawson, to talk about the research they're doing and the ways that it impacts their teaching work as well as their work as researchers. We're asking the fellows to make at least 2 contributions in that sense to various arenas inside and outside Dawson over the course of the year. The third mandate, again, like the teaching community of practice, the researchers will put together a portfolio. So we just finished this term with our sort of discussion community, and those portfolios will go live at some point in the fall of 2021. The research portfolios, they'll be available on the Dawson AI website. And we have a 4th mandate that doesn't apply necessarily to all the researchers and actually doesn't really apply to this first cohort, because what we had an idea to do is that in part we're underwriting and supporting research that is already in some sense underway. And the researchers that we have this year are all engaged in projects that they were already engaged in. And what we're doing is supplementing funding and release time for those projects in order to help underwrite them, but also so that we can get this interdisciplinary community of practice together and enhance all those projects. We have a view to also start using the research community of practice to bootstrap up projects and use it basically as a grant writing support mechanism, so that we could offer some release and some support and some feedback for researchers who are perhaps new to looking for external funding. And we will help find and secure external funding so that this could be a self-financing research opportunity for AI-related research at Dawson going forward. So the 4th mandate would be for, if we select fellows for future community of practice who don't have any outside funding already for a project, that one of the mandates will be that they do in fact apply for, we'll help do that with them, but we will help them figure out where to apply and to put forward grant applications to get funding so that their project can continue past the fellowship. So those are our 4 mandates. This term, as I said, we had 4 contributors to the research community of practice. Thank you, Myriam. So Annalisa Aunio is from sociology here at Dawson. I'll introduce everybody just by name quickly, and then we'll go through the projects one by one afterwards, just quickly to give you a sense for what they're working on. So Annalisa Aunio from sociology, Myriam Rafla from cinema and communications, and Patricia Campbell and Victor Ponce from computer science. The first project that I'll just highlight quickly is Annalisa Aunio's project. So she's engaged in a massive and really just incredible interactive food mapping project, which is a project that it involves a lot of student participation. It's a project she does with the students, and it's a huge data collection exercise using both online governmental sources of information, but also old-fashioned pounding the street and knocking on doors and getting actual information from people running businesses and stores and assistants, research, people who work with communities on the street, trying to fill needs and whatnot. And the idea here is to map the food resources on the island, and they have an interactive database which is extremely detailed and that shows exactly where food services are under-resourced and where there are perhaps what are called food deserts in communities that need to be addressed and so on. So this is an ongoing project. Obviously, there's a lot of AI involved in this in a sense because of the data collection, trying to figure out, the students have to figure out how to best represent all this data. And then also they're looking forward to trying to figure out ways to help auto-update this project too, so that it doesn't necessarily even involve ongoing human inputs, but that it could somehow collect data and eventually be able to be continually updated at a high level of granular detail without necessarily somebody punching in every bit of data that needs to be there. So that this project too, there's a side project that's coming out of this, a similar sort of project that not about mapping food resources, but for social isolation. So mapping resources available to people who are socially isolated to get them to be less socially isolated. Same sort of project, different set of resources that are also being mapped in the same way. So really interesting work. Next slide, please. For Myriam Rafla, Myriam's in Cinema and Communications, and she's been working with a group of researchers to develop a storytelling chatbot. It's called Juno, the platform that they put together. And the idea here is the students have to learn a bit about building and training a chatbot using natural language processing, but then also using that chatbot to help script narratives and stories in a dialogical approach. So the interaction between the student, the writer, and the AI, and creating conversations with a conversational chatbot. So that's a really interesting ongoing project that, again, will have some spillover into the classroom. It involves students helping create it, and it will eventually be used in classrooms with students who are doing script writing exercises. For the third project, I'm going to turn this one over to Joel. Joel is part of this one, and he can explain the details probably more efficiently than I can.
Thanks, Robert. And I'll make a quick segue too. So this project, machine learning for service delivery in 5G is a 5G project. And we know that the 5G network will transform multiple application domains, including healthcare, autonomous driving, smart cities, Internet of Things, across Industry 4.0, and so on. This research that's being led by Victor Ponce and supported by Patricia Campbell in the computer science department, in which I'm involved in helping to coordinate, is supported by a MyTax grant. So for those of you who don't know, MyTax organization helps to link industry and academic partners. It's a knowledge transfer program. And we're working in collaboration with Sienna. And Sienna is one of the 4 or 5 large companies that are helping to build Canada's first 5G network. And so this project applies machine learning to improve network failure detection and optimize network recovery for consistent delivery of service that go along with that exponential increase of data and communications that will be enabled by 5G. Importantly, though, this project also addresses a larger goal of integrating college students' contributions into cutting-edge research and development. There's a number of student interns that are being onboarded to this project. We're going through 2 phases. Currently, we have 2 student interns that have been doing research and development, both with a set of university partner researchers in a group doing sort of the theory side, and then we have the other students who will work with the company doing the implementation of the AI algorithms that they're looking at to address some of these research questions. So this is very, very interesting, very cutting edge, and very important for us to get a handle on for the future of curriculum development as well. Involving college students and demonstrating their capacity to learn and contribute to AI topics in and out of the curriculum is a major goal of our initiative. So it's great in a way that we have students involved with all these projects. And that brings us to outreach. Now I'll pass to Carl.
Thank you, Joel. So as mentioned a moment ago by Robert, the fellows of both the AI team teaching community practice and the AI team research community practice are expected to share their newly acquired knowledge and expertise with the larger Dawson community, so that it's not constrained to only the community practice itself. Next slide, please. And one way in which they do so is by leading PED Day workshops. So in fact, all of the 15 AI teaching fellows recruited so far have co-led at least one workshop during one of the editions of PED Days at Dawson College, of course. To give you just a few examples, two of the PED Day sessions these past 2 years were on the text generating AI systems that students can now use to generate their take-home essays. If ever you'd like me to expand on that, I could do so during the Q&A. I think it's a fascinating topic. Another PED Day session reviewed the most popular AI-powered exam proctoring systems as well. So the idea was for our fellows to research these two topics as part of one of the mandates, really, and to come up with useful recommendations that they then shared during PED Days. And by the way, if you're interested in any of these topics that I've just mentioned, most of the slides, not all, but really most of the slides developed and presented during PED Days by the AI teaching fellows can be found on the Dawson AI website. That's what you said at the moment. So you simply have to click on resources, which is circled in red. Next slide, please. Thank you. Dawson AI has also organized numerous public conferences in the past 2 years, which were open to the entire Dawson community. So we had a lot of staff members, in addition to, of course, many students and faculty members showing up, and they were also open to our partners. So we had some members of the OVIA, the Observatoire, for example, joining us for some of these events. And many of the fellows of the first cohort as well gave talks during the most recent edition, which is admittedly not that recent, but of the Humanities and Public Life Conference, which was held in September of 2019. And that's the picture you see. So as you can tell, we didn't organize this during the pandemic. That's when having 120 students packed in one amphitheater was still permitted. So in 2019. And during this conference, so the Humanities and Public Life Conference, we held a total of 14 talks on many different aspects of AI. And these talks attracted a total of more than 1,500 students from all sectors of the college. So that was one of our main outreach strategies for the first year of this Dawson AI initiative. Next slide, please. Now, during the following academic year, so during this academic year, we organized a total of 12 talks, 7 of which took place during the so-called Dawson AI Speaker Series last term. Next slide, please. And thanks to these talks, really, a total of 670 students were reached. So 670 students and faculty members ended up attending at least one of these 12 talks. But really, the good thing with the this online teaching environment is that we could record many of them. So many more students and faculty members ended up watching these talks asynchronously, really. Next slide, please. And this shall be my last. So this term, we also organized the screening of a great documentary called Coded Bias, which tackles the issue of algorithmic biases. And 24 teachers, 24 Dawson College teachers agreed to integrate this documentary into one of their classes. So as a result, more than 1,300 students watched it this past April. And the feedback, I have to say, that many of us have received from our students was overwhelmingly positive. So really, this is a documentary, Coded Bias, that I recommend to every teacher. So that's it for me. So John, please.
Thanks, Carl. So as has been alluded to several times already, a key goal of the AI initiative is to try to improve data literacy among our students. This ranges from understanding how data is collected and used in society and all of the related ethical implications as highlighted in coded bias, for example, but it also speaks to the ability of our students to work directly with data. And there are some faculty members like Vanessa who are adapting their courses to teach this directly to their students. But we also would like to, if possible, impact the college experience more generally. So can we reach social science students in general? Can we reach science students in general, as opposed to relying on individual teachers all developing their own individual modules to address these issues? Unfortunately, working with data tends to be unwieldy. At least interesting data tends to be very unwieldy. And so to get over this hurdle or this obstacle, we're trying to develop some, I would call them nascent data literacy initiatives to introduce very general data skills that really any student should be able to access. Would you mind going to the next slide? And so for maximum impact, we're trying to run these pilot projects in the social science program through the quantitative methods course and through the science program through the mechanics course. These are courses that every student will take. And the idea, as I said, is to introduce new tools that will facilitate working with data and integrate very basic programming techniques into the learning activities of existing courses. This is very much akin to like the late 1990s, early 2000s, where we wanted all of our students to see Excel and learn how to use Excel. We didn't make a new Excel course. We just tried to bring Excel into existing workflows or existing learning activities in the courses that they already saw. So we ran this pilot in mechanics this year in a few sections. And I think the plan is to try to run it in QM next fall. So these are two examples where we leverage the Python ecosystem. Python is sort of well known for being an accessible programming language. Specifically here, we're using Google Collaboratory. The nice thing about using a platform like Google Colab is that the student doesn't have to install anything. It's all done through the browser, and you have access to really a very rich ecosystem of libraries and packages. By showing them this platform or this framework, we allow the students not only to do the usual analyses that they would carry out with Excel, but we open the door to the possibility of much, much deeper analyses. And contrary to what you might have heard, once we have students sort of in the ecosystem, it's really not that hard to go very far. It doesn't require, things have advanced to the point where it doesn't require a ton of programming skill to really carry out pretty detailed analyses that would be basically impossible to do with Excel. And to give you an example of what's possible, I'm going to pass it to Jaya to show us a little work on character recognition.
Hey, good morning, everybody. I'm Jaya. I'm from the computer science department. Myriam, could you pass on to the next slide, please? Thank you. So I'm going to walk you through a bit of an interactive part of the presentation. So I've put up in the chat a link to one of these Python notebooks. Requires you have a Google email account or a Google account. So if you want to follow along with me, go ahead and open up that link. Myriam, if you could open it up as well, we could walk through this together. So John had mentioned that one of the big advantages of using Google Colab is that it's available to everybody. You need to have a Google account. But other than that, you don't need to install any other software on your system. All of this AI stuff is running magically on Google's platforms in the cloud. So you got access to a lot of horsepower, which is one of the reasons why AI is a lot more accessible than it used to be just a few years back. So we could see it up on the screen. I don't know if any of you are having trouble. I don't know if we're allowed to do this, but maybe you could just interrupt or put your question in the chat and one of my colleagues could answer your questions. So the goal of this notebook was to introduce students, well, we're using it with you today, so it's to introduce you to kind of the steps that are taken in an AI or machine learning system. So there's a training step and then there's testing steps. And what we're doing is we're recognizing handwritten digits. So this image recognition is one of the basic kind of recipes in computer vision. And We just wanted to give you a feel of what that's like now and how much programming skills you need to know to follow what we're doing. So we're using this database, which is called the MNIST database, which is a collection of a lot of handwritten digits collected over years. It's pretty much the standard that's being used for computer vision, or that was being used for computer vision. So Myriam, if you could scroll down to the setting things up section. So this entire thing is a notebook, and what makes a notebook interesting is you've noticed that we've got a mix of text, which is explanatory, explaining what we're doing and why we're doing things. And then you could see that gray cell, which is code. So we've got the two of them together. What's really interesting about this is it gets students into the mindset of reproducible research, that within this one notebook, we've got access to the data set that we're using. We've got access to the explanation of what the hypothesis is, and then the code, which is actually doing the training and the testing of the AI system. So all of it bundled together and then shareable. So just the same way we're sharing this with you, students can share it with each other, with their teachers. So if you notice, one of the first items of code is a bunch of these import statements. And this is what John was referring to. Machine learning has become so accessible because there's a lot of packages which are out there. So all of that heavy duty mathematical lifting and understanding of the algorithms and coding of the algorithms has already been done. And what's left is to understand, how to use these packages, which one to choose, and then how to decipher the results coming out of it. So probably the hardest part of machine learning has been taken out. And what's left is understanding what the recipe is. So if you notice, the next section is working with the data set in Colab. So what we've got is, because we're working with Colab, we've actually got some data sets which are built in. So we're using the MNIST handwritten digit database. That line of code over there, which you see, which is the digits equal pandas, blah, blah, blah. What that's doing is it's reading a CSV file, and you can think of a CSV file as kind of like an Excel file. It's got rows, it's got columns, and we're reading that file and assigning the result of what we're reading into this variable called digits. So here's a bit of Python code where we're seeing, I've chosen a variable called digits. The reason why I'm doing that is I want to be able to refer to it later on when I'm going to want to programmatically check out and see what's within that CSV file. So that one line of code is taking care of me uploading and getting all of that data set ready for me to use. And if you scroll down a little bit, the next coding block is me trying to find out now some more information. Okay, so I just read the CSV file. We don't know anything about it. You don't know what these digits are. We kind of have to figure this out. So the line of code where I'm asking the digits variable, which is basically that data frame which contains that CSV file, I ask it what its shape is. And what you notice is it's got, replying back saying it's got 20,000 rows, and each row having 785, better put my glasses on, 785 columns. Yeah, that's right. So what that's signifying is I've opened up this data set, which has got a sample of 20,000 handwritten digits. And the way these handwritten digits have been somehow specified is through these 785 columns. So kind of doesn't make a lot of sense yet. We're talking about digits, right? Why do I need 785 columns? So if you scroll down just a little bit, you'll see that if I actually take a look at that digits data frame and what it contains, here you have an idea of what each of the rows contains. And the very first column, so Myriam, if you could scroll back the other way, the very first column, you'll notice it kind of is telling you what the digit is that's represented. So in row 0, when you're programming, we always start counting with 0. So just when you hear me say row 0, I mean the first row, you can see that that's should be by what I see in column 0, that should be what that row represents is the digit 6, and row 1 is digit 5, and so on and so forth. then that's followed by 784 columns, which looks like a whole ton of zeros going on. So what actually is happening is each of those columns are representing a pixel in this image. So it's a 28 by 28 pixel grid. So 28 times 28 is the 784, and that's what each of those columns are representing. And so depending on whether, when in the process of in a 28 by 28 grid, when you're drawing out your handwritten digit, if it's blank, so that pixel has no intensity, there's a 0, and that's why we see tons of zeros. But then depending on whether your pencil is going into the pixel or not, in fact, the intensity is going to vary between 1 and 255. So that's what each of these rows are representing. We've taken out the image of the digits and looking at it pixel by pixel. Now that's kind of abstract, right? And if I was a student, I would be like, pixel, what? So if you scroll down a little bit, you get to some code where what this code is doing is it's taking the first row out of that digits data frame and taking out of that the label, which is label being the digit that's represented by that row, and then just displaying what it looks like. So we're taking that 28 by 28, we're putting it into a 28 by 28 grid and displaying it as an image. And so that's what you see below, that's the label, which is that first column is saying that this is an image 6, and what you actually see is a 6. So we're introducing now the students to the concept of labeled data. When we're doing any kind of machine learning, or supervised machine learning, we need to know what the data represents, because this is what we're going to be training our system on. So what we've got at this point is we've got 20,000 samples of handwritten digits, so collected over time, looking like this, right? It's in a 28 by 28 grid. Each digit is a separate row in the file. We know what each digit represents, which basically means a human has painstakingly written down, oh, this is a digit 6. And so a human has labeled it. So we know what each row is. And so we're going to be using these 20,000 samples to train an AI system to recognize handwritten digits. So Myriam, if you could just scroll down to the discussion part. So some of the things that we can ask ourselves is, this is how training works. We've got labeled data, and we're using this labeled data in order to say, well, these are what digits look like based on the labels, figure out what a 1 looks like, and so on and so forth. How would you know whether you've trained a system correctly? Like, how would you actually test a model once you've done the training? Anybody in the audience want to have an idea or want to speak up?
You can see how it performs on data that you didn't give it. So unlabeled data, and then, you know, something that you have labels for, but the machine algorithm hasn't seen before.
Oh, wonderful. Why is it important that the machine algorithm hasn't seen that data before?
Data has noise. So if you're training something on a certain data set, it's also going to fit the, you know, if you're doing a bad job, it will fit the details specific to that particular image set.
Yeah, exactly. So Emily knows what she's talking about. Sorry I put you on the spot. Why? But what she said is exactly right. You don't want to take the risk of, if you're using the same data you used to train your system and then use that same data to test it, you end up with the risk that your AI system just memorizes. It just says, oh, these are the only ones that I'm ever going to see. So on this training set, I'm going to have 100% performance. Everything's going to be accurate. But the second it sees something outside of the training set, it may actually fumble really badly. So it's really important when you're testing to be using a separate set of data. How about the fourth question that I've got in there? What could possibly go wrong, or what would be an impact of me using this AI system to recognize handwritten digits? And if something goes wrong, is there a big impact, or how would I know that something went wrong? So I'll answer the question. Okay, Jaya. So one of the issues with AI systems, and which is important that students get a feel for it, is depending on what we're going to be using it for, if something goes wrong, the consequence could be minimal. Like, oh, well, who cares? I misrecognized a digit, but I'm going to be asking the user for confirmation, or I'm going to have a second user confirmation step, so it's not the end of the world, versus let's say you guys have all used the banking systems where you're taking an image of your check. And when you're taking an image of a check and you misrecognize the digits, there could actually be a bigger kind of financial impact, and that financial impact could affect an actual user, not just affecting the big banking organization, but it could affect a user by taking too much money out of their bank account. So there are, depending on what you're using your AI system for, the students and us around this table here, we kind of need to be aware that there could be some unforeseen consequences, and that makes a difference. That makes a difference. You can't just put a system out there without understanding how things work. So my fifth question over there was, we're talking about these handwritten digits, and let's say that I've got this case. I don't know if it's true. I just made it up. But let's say that geographically, some areas, people are generally writing their fours with a closed top, so looking more like a triangle. And in other areas, people are writing their fours with an open top. And let's say I've been collecting all of my data for training in one area. So is this a big deal, and how can I think about the impacts of what could happen based on me having, this 20,000 data set? Sometimes things like that might end up being lost, or details like that might end up being lost when I'm looking at how well my system's performing. Do you think this is a big deal? And if it is a big deal, how do you think we could go about mitigating? Oh, Jaya's going to answer again. Well, Jaya thinks that this is a big deal, because behind the scenes, and this is one of the reasons why I'm from computer science, and it's a really big load on a computer scientist if you're expecting us to be thinking of and being aware of all types of possible things that can go wrong when we're training up an AI system. We don't necessarily have the sociology background to know that, oh, I should have collected my data in a bunch of different regions because this region people are closing their force. Or we don't necessarily have the cultural background to know that some people or some things may react differently in certain situations, which is one of the reasons why the Dawson AI initiative was trying or wants to get AI and some kind of understanding of AI available to all students. Yeah, so I'm going to keep moving on here. So if we go on to the training and testing portion, what we did is we're using a support vector classification model to do the training. And if you look at the next code block, there's just 4 lines of code. Okay, so those 4 lines of code are all that we need to train a system. And at the end of that, if you're running it, it's going to take a while. This is going to take you about 5 minutes to train the system. It would take a lot longer if you were running this on your computer at home, but on Google systems, it takes 5 minutes. So you don't have to run it. It's already been trained. And if you scroll down, what we do next is we're testing it. And so when we're testing it, we're on a different data set, like Emily proposed. We've opened up a second data set, which is just now a new 10,000 more handwritten digits. And we're testing to see how well does our classifier predict. So these are, again, labeled data. We know what a human thinks it is, and we're going to see whether a classifier thinks it's the same thing. So what we're doing in the code is we're basically separating out the labels from the images and then passing those images to our classifier to see what the classifier thinks. And if you scroll down, what I've done is I've just taken the first 10. We don't want to visually go through this because I've got 10,000 in my training set, but I've taken out the first 10 rows just to see what my classifier classifies these digits as versus what they really are. And you can see it's doing pretty well, right? Like the labels, which are what a human thinks they are versus what the prediction is. It looks pretty good until all of a sudden it starts choking near the bottom. It thinks a 9 is a 3, it thinks a 5 is a 6. So it's not perfect. We could see that just by this little 10-digit sample that it's not perfect. So if you keep scrolling down, you'll notice that the score that it gives itself based on the testing images and what the actual results are, it's about an 89% score. But what does that really mean? So whenever we're talking about AI systems, you have different measures, and depending on who's trying to sell you the AI system, they may talk about one measure, or they may not talk about another measure, or they may not actually specify what measures they're talking about. So part of what this notebook includes is just an explanation of what a precision means, what recall means. I'm running tight on time, so I won't go through it. There's also this confusion matrix, which sounds very confusing, but what it's showing you is whether there's specific digits which are causing more issues, which are causing more false positives or false negatives. So that's what that confusing matrix is, which if we had time, we'd go through it. And then the next steps, which I think would be important for any student, and regardless of what program they're coming from, is to see, all right, we've done something, we can't just leave it there. What would be the next things that we'd want to do? And then depending on whether the student's coming from more of a STEM background, maybe we'd play around with the algorithms, try to find a better one, try to tweak it around. Or if a student's coming from a more of a social science background, we could look at other ways, what does the data collection mean? Did we have enough data? What could be other uses of this classifier, and start building other things. So a little bit of agency is what we'd be wanting for the next steps. All right, thank you very much. Sorry. Oh, sorry, I'm passing this on to Joel.
Yes, thank you, Jaya. I think what these developments allow us to see is that the barrier to entry to these AI topics and the ability to actually work in technical domains is coming down, and there's a great potential for what students can do now. And also, it allows us to see a snapshot of the overall strategy for integrating AI competencies into programs and to look ahead. So we want to leave some time for Q&A, but we have a little bit more material to cover. And please, next slide, Myriam. And just to talk a little bit about the core strategy and some of the initiatives that we're working on for the next year. So the core strategy is capacity building, and capacity building within institutions is needed for adapting to education challenges in the AI era. You can't hire this problem away. There are also clear links with ongoing research projects with some of our external partners that tie in with our institutional goals. So for example, with a grant from PIA, the Pôle Montréalais d'enseignement supérieur en intelligence artificielle, we're working with Concordia on an AI competency framework modeled as a pipeline for success for college, university, and mid-career learners. This will be presented as a poster in another session today. Nova Science, where we're exploring the use of AI-powered intelligent tutoring systems for teaching and learning AI-relevant competencies. And finally, it's important to get to engage all stakeholders, and for that one needs a great team. So Myriam Dimanche, who is an indispensable member of the Dawson AI team and is helping to coordinate all aspects of the initiative. Myriam, I'll pass it to you now.
Thank you, Joel. As you mentioned, as project coordinator of the AI initiative, it's really been a pleasure to support our teachers, our teaching fellows, as they develop AI-themed modules for their courses. Now, these teachers, they don't just come from the computer science department. We've been quite fortunate to have fantastic fellows from various disciplines across the college, not just mathematics, but cinema communications, humanities, philosophy. The portfolios they've developed are available not only within Dawson, but publicly, so you can see on them providing virtually turnkey learning modules for teachers wishing to implement AI-themed content into their classrooms on our website. So we encourage you to browse www.dawson.ai to check out these amazing resources. Now, speaking of resources, you may be asking yourself, well, how does one even begin to undertake the task of bringing AI education to the classroom? And what tools are available to facilitate the process? So as part of our research initiatives at Dawson, Dr. Bhatnagar is working on this question and is leading a project on intelligent tutoring systems with one of our industry partners, Corbett Technologies. So I'll hand it over to Samir.
Thanks, Myriam. So Corbett, everyone should check it out. It's called Corbett.ai. It's a Montreal-based company. And I like to think of this, in this presentation, we've alluded to, and I think just like 2 slides ago, talking about 3 years and beyond. Well, this is the beyond part, okay, of the presentation, because I remember when MOOCs came out, massive open online classrooms. This is maybe 10 years ago, and it was just a crazy idea that people would log on and try to learn by themselves through videos. And so maybe back then that was the beyond. And now we see that MOOCs are actually a pretty reliable big part of even general education. I know my students are regularly going on to Khan Academy, are regularly signing up for extra help, more so during the pandemic, but the students have now incorporated what used to be a beyond technology, these massive open online classrooms like Coursera and edX. They've kind of leached into what is classical in-presence education, I'd say. Well, so what's the beyond now? Well, beyond now is what Corbett is. Corbett is a chatbot, and it's the idea and the market that they're after right now is to make MOOCs even more adaptive. So instead of having a student watch a video, if you've ever taken an online course, you know, it's a recipe. Watch a video, do some exercises. Watch a video, do some exercises. And the exercises are kind of, you know, the best we got is some drag and drop, some multiple choice. Open text response is not really there. It's still pretty static, even though we're 10 years into the MOOC game. Well, Corbett really blows the lid off and is now, they've got lots of interesting exercises, but it's not watch a video and just do this exercise. It's a little AI trained natural language engine whose name is Corby, and it will, you chat with it like as if you were to have a tutor next to you. They're really pushing the envelope further than any company I've seen, you know, in terms of education. And so now this is this new tool that we are, I think, at the nascent phases of it. And so I think the opportunity that the Dawson AI initiative has afforded the community here is to explore, well, what will this tool, how will this tool leach into our teaching 10 years from now? How can a AI chatbot where students, you know, when I give my students a reading, when I give them a resource to do, I go tell them to do it. And then I often, you know, if you have an online tool that you use like an OpenStax or something like that, your students will go, and then you have probably a back end where you could see my students did this question and this question and this question, and which questions did they get wrong the most. That's a classical teaching aid. Well, what happens when a chatbot like this becomes the teaching aid, where I tell my students, go do Corby for 20 minutes and see if Corby can figure out what your misunderstandings are. Well, how does that inform my teaching practice? It may not really be ready for it today, but in 10 years, this will be a tool that teachers will use, these chatbots that students are interacting with. How can I get a report as a teacher that helps inform my teaching practice? How do I guide my students through something that is very non-deterministic? And so that's what the Nova Science Project is about, is really looking at that beyond, is what are the tools of tomorrow that may seem kind of wacky right now? To be honest, like it had the wackiness of Corbett, the way I feel about it sometimes when I think about how is this a tool today, is what I felt 10 years ago thinking about MOOCs. But it is going to be a reality where we're going to have more and more of these chat bots that students can engage with as online virtual tutors. And if they are going to become part of the landscape, how do we as teachers adapt and leverage the power that they have, right, to make it so that our in-presence practice is richer for it? And that's what the Nova Science Project is about, and building that collaboration between industry, where Corbett is a private sector company with a, with a corporate mandate, and us as a public institution who lead the education forefront. How do we collaborate? And Concordia is a part of the grant. So how to interorder, like we've been talking about interdisciplinary for quite a bit. This is a nice this grant is interesting because it's also interorder. And how do we collaborate between private sector, university, college, teachers? Like, how does that fit together? The Nova Science Grant is about that. So the Dawson AI initiative was cool because it's really a unique place to kind of explore what beyond could look like. Thanks. Great.
So you get the sense that there are many, many dimensions to this, to the initiative, but also to the issues around that artificial intelligence presents us. And so there's a way of imagining this as a kind of a bottom up meets top down. So you have a grassroots movement involving a lot of members of a community coming together for capacity building, and then you have the needs of society as a whole. And so how do you get this over time into your programs and to the students? So we're just going to quickly go through three examples of things that we're working on and that will be unrolling in the near future, that don't only involve AI directly, but also education at the college as a whole. So pass to John.
Yeah, thanks, Joel. You mentioned briefly the PIA grant that we're working on. It's a massive grant between basically Dawson and Concordia, whose aim is to create an inventory of all AI competencies from both technical, business, ethical, sort of the whole gamut. And if we recognize that AI competencies are probably something our students are going to need in the not so distant future, the question naturally becomes, how can we integrate some of these competencies into the programs that we offer at the college level? Next slide, please. As everybody in this room is probably very, very well aware, program competencies are set in stone by the ministry at the SAGEP level. So we can't really decide to drop in 3 or 4 new competencies that we think will be useful for our students. But that doesn't mean that we can't do anything. If we look at the current deck in science, the 200B0 program, which is under revision at the moment, a lot of the competencies in the AI framework that were identified in, say, math and stats are already part of the science program. You need to know how to calculate derivatives, you know how to calculate integrals, and you know basic statistics. These are things that our students get already. So we cover a lot of bases on the technical side. Programming competencies can be introduced at a low level, admittedly, through learning activities in existing courses, like we already discussed with the QM initiative and the mechanics initiative. We can give basic Python skills, just like we give basic Excel skills now. And we do have option courses in the science program where we can provide students an opportunity to do a deeper dive on the, let's call them, hardcore AI competencies. And we also have complementary courses and humanities courses that can tailor their flavor a little bit towards some of the ethical issues around the use of AI in modern society. So we can imagine that in the future at Dawson, post-revision, we may have something like a computational science profile within science that sort of gives students a path to pick up some of the key competencies related to working with data and machine learning and AI more generally. There's also a deck in math and computer science offered by the ministry, 200C0. It has no option courses, but with the, I think, 4 required computer science courses, there's ample opportunity to introduce AI learning activities in a program like that. That's for science, which obviously is ready to tackle AI maybe from a more technical perspective, but it's not limited to science. Rob.
Thanks. One of our efforts also has been to try to see how can we get this kind of content into non-science courses as well. So we're taking advantage of the fact that social science is nearing the end of its revision cycle right now, and we're at the point of proposing and figuring out what the profile structure at Dawson will be that should go live in fall 2023. So we have proposed, and it has been provisionally accepted, a profile at Dawson called tentatively called Technology and Society. which will not be just AI themed content, obviously, but it will serve as a home for a number of courses that will, of course, have AI themed content and data literacy content. There are a number of faculty who are involved in the drafting of the proposal for this profile who are excited about being part of it when it happens. The courses that will actually populate the grid are to be determined in the fall, but we already have numerous course proposals from political science, sociology, philosophy, psychology, economics, geography, anthropology, religion, pretty much all the disciplines in social science. There's at least one faculty member who's super interested in designing courses for this profile. And a number of those teachers have been or will be in the coming fall fellows of the teaching community of practice. So this is a really exciting opportunity where the sort of rubber can hit the road in terms of all these teaching portfolios that have been put together. We might get a natural home, and there could be a lot more course sections devoted to having the possibility of this content being in those courses and reaching students, perhaps a gigantic number of students. We're not sure exactly how many students a profile like this will draw, but we're pretty hopeful that it might turn out to be quite popular.
And then finally, we have the goal, the stated goal of the initiative from the outset was how many students can we impact? You know, in principle, we'd like to reach all students. In practice, that's difficult. So you see, there are different elements of a strategy to target different programs and different groups of students. But there is a way that you can do this flexibly within the institution. So at Dawson, we have certificates, which is not like certification you would normally think. It's more like a minor. So a certificate at Dawson provides a thematic area of concentration that complements a student's program. And so this usually involves coursework, co-curricular activities, something like a capstone project. And there are several certificates at Dawson that have their activities rooted in an interdisciplinary field of study. And what we're proposing and we'll be working on for launch through next year and year 3 is a new AI theme certificate, which would allow in principle all Dawson students to gain exposure to topics in artificial intelligence. And this provides some, let's say, redundancies for some of the curriculum development and program development work that we're doing, and kind of a container, if you will, for many of the teaching modules that have been developed, and a way of bridging across programs, across sectors, an ongoing and evolving community of practice. Next slide, please, Myriam. So we want to leave enough time for Q&A, but that's really that's what we're really looking to. What will be the future of this initiative? So AI a few years ago was a buzzword, and maybe not that well defined, is becoming more and more understood, and of course we understand the need to address the issues that AI and related emerging technology fields raise in education. And so we're not only thinking about AI, we're thinking about the, sort of the future of education. And with that, I just want to say thanks on behalf of all the speakers today, and I hope we have enough time for some questions and discussion. And would just like to say that if anybody is interested in what we're doing, not only visit the website, but feel free to reach out to us. Part of what our hopes were for today was not only bringing some information and awareness about what's happening at Dawson, but also an invitation to collaborate and to work with others in the network, both in college and across higher ed. So thanks again on behalf of everyone who presented today and the Dawson College. Thanks.
Thank you so much to our presenters. So I think that the keynote presentation will be starting in half an hour. So I think we can take at least 15 minutes here to ask some questions. So please feel free to leave your questions in the chat or raise a hand and you can unmute yourself to ask your question.
If there aren't any questions directly, Jaya, maybe now's a chance to come back to ask one of the questions that you left off of one of the questions you left off of your demo.
I don't know where.
Or maybe to say that like handwriting character recognition seems like a small problem, right? When we scan our checks on our phone, I mean, it seems like the range of application is fairly limited and probably something we don't need to care about that much. But writing out a character as a string of ones and zeros, or a string of numbers from 0 to 255, and codifying a face as a string of numbers is actually the exact same problem. So in 4 lines, she trained a computer to recognize 10 digits. It actually does not take that many more lines to recognize a face. It might require a slightly more complicated package, maybe an OpenCV package. It might only be 4 lines of code still, but you can see how very quickly our students could build a facial recognition system if they wanted to. And that because this technology is free and openly accessible, which is a good thing, anybody can, almost anybody can do it, which is really why the initiative, we try to tackle the AI question from so many different perspectives, because without an understanding of the ethical implications of such technology, it will be definitely used, maybe not with a bad intent, but it could have bad outcomes just through ignorance. And so I think that is something that sets the Dawson AI initiative apart, this holistic view of this technology and how it's important, not just for our computer science students to have a competitive edge in the marketplace, but for all of our students to have an awareness of the issues around AI, what's kind of happening behind the curtain, what good can come out of it, because there are a lot of good things when we look at things like the accuracy of AI systems to detect anomalies in medical imaging is better than specialists, but a lot of bad can also come out of it, as enumerated in several of the talks that has been organized through the Public Life Conference, the Bhatnagar, and so on. I hope we don't come across as just an initiative that's trying to give our students technical skills. It's really much larger than that. And I think it makes it much more relevant to this age group.
That's a great point, John. Just the mandate of college education too, which is, to develop the whole person and to help prepare students to be contributors to important public conversations. And so when we look at something like an exit profile and we start to think about, what are the global competencies that students are acquiring, and one of those that has been talked about and is evolving over time is this idea of quantitative literacy that's becoming data literacy, that will become digital literacy, and the whole experience of digital transformation that we're living through right now. And it's important for students from all disciplines and backgrounds to be able to contribute to those important public conversations.
I just want to add my favorite part of Jaya's notebook. We didn't get to at the end, and I think just the point to make is there's a whole section on error analysis. So where does it go wrong? Okay, where does it? And that we're doing this in our computer science class right now with science students. It ends up leading to a really rich discussion about, it's not a lot of the science is not about what's in the black box. It's how to evaluate the outputs of that black box, because that's where the societal impact will be. And so, like, what is precision, and what would that be? What's recall? Well, recall is defined as the number of numbers that I was trying to identify, but I got. But the thing is, that's really important in the medical context. And so we have students who are like, "Oh, sir, I did great. I just trained this classifier. I can detect, stroke patients having death events and stuff like that." Right? But precision is 90%. And it's a super rich discussion. I love having it. And it comes out from the end of JS Collab, where it's like, yeah, but what's your recall? Oh, it's like 4%. So of the people we want it. So in the medical context, recall is so much more important. Maybe it's not important for handwriting recognition, but it's the same 4 lines of code that do it for in medical data sets. And so the discussion of like the task, the box you use for the task, and then separating out the critical thinking all around it. And if we're trying as the Dawson AI initiative to like foster critical thinking, it ends up being a really rich ground for discussion in these kinds of contexts.
We have a question from the audience. Emily says, I love the focus on bringing social scientists et al. Into basic AI competency to bring them into the conversation. The MNIST notebook is great. But going the other way, what are some education initiatives that have been productive that bring the highly technical skills and collaboration with the social science discussions? I'd also love to hear more about how the technical side people are trained in effective collaborations with social science side people.
Maybe Rob, I mean, Annalisa's project would be an excellent example of the first situation, no?
Yeah, I mean, look, it can be difficult. I will say that. I mean, part of what's great about the AI initiative here at Dawson is we're making a real attempt to bring interdisciplinary groups together to work on this, because it is difficult, you know, to work with a bunch of, say, social science students on a massive data-based project. There's a pretty steep learning curve in terms of the mathematics alone sometimes, because the nature of programs is such that they generally, you know, they can take, some of them in social science can take math but in some profiles, but not all profiles, for example, right? Pretty much no students in ALC, for example, take any math. So if you wanted to do some work like what Myriam Raffel is doing with her students, then there's definitely going to be a learning curve because of the lack of opportunity to necessarily take the required courses that one might need to get going. So it's really helpful to work across the aisle in this way to figure out ways to quickly and effectively get social science or arts students up to speed on the technical aspects so that you can do interesting things. On the flip side, it also has been interesting to see the degree to which some people on the STEM side have or haven't engaged with those sort of social and ethical questions. And we've had some pretty spirited debates, Carl can attest to this also, within the teaching community of practice. I mean, there are those who think some of us are too technophobic and others who think we're not technophobic enough and we ought to be more concerned. It's difficult work. I think the idea here is that if eventually we can maybe get, especially through initiatives like potentially the AI certificate, an opportunity to get students from different disciplines in the same classroom, because now we're getting to the point now where we can get faculty from different disciplines together to work on ideas and engage in collaborations. It's still difficult to get students from different disciplines in the same room outside of general education. And that's a whole other beast of maybe trying to introduce this content there. Eventually, potentially, we could have some courses where we could get that kind of interdisciplinary work, because it is really interesting. And I think it is the future that we need, right? We don't need, you know, this is what we've heard from the advisory board too, repeatedly, is that we don't need students that can necessarily understand the technology perfectly. What we need are students who can understand the technology, but also understand the social and ethical implications and can understand what kind of questions to be asking about the work as it's undergoing. In fact, at a recent talk, many of us were there. Someone said something interesting, which was that it's worth talking about all the sort of negative aspects, because the positive aspects of this technology go without saying, right? The benefits that they can bring to society go without saying. That we need to have the conversation about the potential negative sides, dark sides, because otherwise we're just sort of blindly running towards a future that we don't know what it will look like. Carl raised his hand. I think he probably wants to jump in on this one too.
Yes, please. If I may just add to what Robert was mentioning in answer to, again, Emily's question, right, I think that Rob is absolutely right in pointing out that for social scientists, it is challenging to be tackling these technical issues as part of our classes, because we cannot assume that our students have any computer science technical background, right? So that they would understand even the notebook that was used by Jaya today. So it would take us some time to be teaching that. However, there are many examples of some of our past AI teaching fellows who are actually hardcore scientists, teaching to students who already have this prior technical background and who are trying to integrate into their classes some of these social and ethical implications of AI technology. So if you were to have a look, for example, at the 2020-2021 cohort of AI teaching fellows, just to give you two examples, you have Daniel Pomerantz, who is a computer science teacher, teaching to students who have, again, a lot of prior knowledge of coding. And in his newly developed course is going to tackle, so devote many different classes to these social ethical implications. And the nice thing is that Daniel and I'm an applied ethicist by training. So Daniel and I, in our meetings during the community practice, we could exchange resources, and I've shared a fair number of what I see as reliable sources of information on applied ethics on these questions that Dan, as a computer scientist, can integrate into his class. And the second example that you can have a look at on the Dawson AI website would be Gary Chu. And Gary is a math teacher, again, teaching to lots of health science and pure and applied science students with this, prior technical knowledge. And math and Gary in the future will be attempting to tackle the issue, notably of algorithmic biases to students already familiar with coding. So we do have these attempts amongst some of the past AI teaching fellows. And again, you can learn much more about these attempts if you were to have a look at Daniel Pomerantz's portfolio and Gary Chu's portfolio, which are available on the Dawson AI website.
Just one more point to raise about the overlap. It's been mentioned, one of the grant projects that we're working on. John elaborated a bit more on it. This PIA project, the AI competency framework. This thinking about learners across the higher ed spectrum. The approach is to look at competencies in these different focus areas: technical, business, human skills. And the approach to this project has been to take ethical skills and dimensions and weave them through all of these discrete areas. So you can focus on these different domains, but we have to understand that ethics permeates all, right? And that has been like a core feature of the conversations that we've been having at Dawson about AI technologies, the impacts on society. And it's a wonderful entry point for all students, because of course they all go through general education, and so you have the opportunity to be able to reach them in that sense as well. And so taking a global approach to some of these interdisciplinary issues it's easier to look at the impacts than it is to say everyone needs technical skills. Not everybody needs technical skills to participate in this conversation, but we'd like to expose as many students as possible to the technical side as well. I think Robert or John had their hand up first.
Well, I just wanted to say, I think Emily, her question hits on a more fundamental problem, and that is that the people who have the technical skills, often the teachers, don't feel competent to address the ethical issues because they're not ethicists. And in the social sciences, you have the opposite. Teachers, we've seen this when we do coffee and codes, for example, teachers from the social sciences, humanities, ethics, don't feel competent to teach to their students the programming competencies. And I think that is the whole point of the teaching community of practice, is to put in the same room people from these very different backgrounds to see, well, to demystify a little bit the other side and to help each other integrate these complex ideas that aren't necessarily our expertise into our own teaching practice. And the teaching portfolios are excellent for that, because there's many examples of how in a technical course you can integrate ethical ideas, and how in a course that touches more on ideas related to the humanities, you can integrate some technical ideas. It's hard to do it on your own. It's hard to do everything on your own. I applaud Vanessa as a political scientist to just dive in and be like, I'm just gonna do everything. But it's not every faculty member that's gonna do that. So go ahead, Rob.
Yeah, I won't take up a lot of time. Just two quick suggestions. One, a practical thing that can be done with students, which they quite enjoy, is to do sort of a black hat exercise. So you can do this with technical students too, right? So that, like, working on a technology, but just to think, if I were a bad guy, or if I were someone who really wanted to do something terrible or make money from this in some unethical way, could I, sort of. But it's interesting to get them thinking in terms of that. Like, so what could be the possible misuses and abuses? And to come to a question that I just saw in the chat from Joseph, what are the differences with AI technology as opposed to the standard sort of ethical and social challenges of any technological revolution? The main one is really just the speed. I think that's the speed of change, and the amount of change that's going to happen in this short amount of time is really the big difference. especially just on the legal and regulatory landscape. There are gigantic implications that unless people on the tech side are thinking ahead of time, what is the legal and regulatory landscape going to look like that these technologies are going to be released into, and on the social science side, knowing what is coming so that they can start having those conversations. It's the speed, I think, is the main difference here, which is why we're working hard to get this up and running in an interdisciplinary way as quickly as possible, because the students of the future, the very near future, are going to need it, I think.
If I may just add one point, I mean, the speed with which these technological changes occur, I think, it is clearly a relevant aspect to tackle, but also I would argue the nature of these AI technologies as well, raise all kinds of new ethical issues. And that's why, by the way, I mean, as I'm sure you're aware, Professor Joseph, but there's a sizable body of academic literature about both the AI ethics, but also the ethics of algorithms. So in Montreal, we do have a research center sur l'Observatoire sur les changements sociétaux de l'intelligence artificielle, which is devoted to tackling these unique ethical questions raised by the nature of these AI technologies. So, I mean, the list is very long, but we gave you one example. The algorithmic biases is pretty unique ethical question to this specific kind of technology that, would not be an issue with previous technological revolutions. So that's just one, but also the kinds of jobs that might be replaced by these upcoming technologies is a different consequentialist, so ethical question. And it's being debated right now, but it's not impossible to believe that a lot of the distinctively human work, what we've been perceiving as distinctively human work, will be replaced by these AI technologies in the future decades. And this in itself brings up a number of ethical questions.
I think we're eating into the break, Hillary.
Yeah, I was just going to say, I didn't want to interrupt because I saw some mics unmuting. So there's certainly, I don't need to cut off your conversation. Just a reminder to everyone that the keynote is starting at 11:15. So now is technically a break time. I can keep this room open until 11:15. And just a reminder, if you would like to continue conversations, the conference platform does allow for direct chat to each other. You can also see each other's contact information in your profiles too.
We highly encourage you to stay in touch if you want to continue the conversation. It's beyond the symposium. We're only, I think, scratching the surface of what's possible and what we need to address within education on these important topics.
So if I could just, can you hear me? Yeah. So if I could just play devil's advocate. So you mentioned speed. Yeah, sure. Fair enough. But I mean, the idea of bias, I mean, you hear a lot about this, but police have been using data sets to guide policing well before AI became a thing, and they were subject to the same kind of biases that we're concerned about with AI. AI is more powerful, so it amplifies those biases arguably, but it's not clear to me that that's new. And the other thing is, in terms of whose jobs get replaced, one can't help but wonder that if all the excitement about AI is the fact that the jobs that are getting replaced are white collar jobs, which hasn't been the case in the past. So is that really new that jobs are getting replaced by automation? No. Is it new that white collar jobs are being replaced? Arguably, but is that, does that just reflect, the unbalance of our society, that suddenly this is getting a lot of attention? So I don't want to have a whole debate about that, but I just wanted to mention that just wanted to push back a little bit about the idea that these issues are really specific or new to AI.
Yeah, I totally hear what you're saying. And I would say that maybe there's one dimension that definitely seems new, which is autonomous judgment of systems without human input, right? So in the past abuses, and all the instances in the past where we've used data to help potentially oppress people and whatnot, we may be reaching the point where we're completely skipping over any human judgment stage, and the systems themselves will analyze the data and make the recommendation and execute the recommendation, right? At a level that is definitely new. And then the flip side problem of that is it comes with this implied objectivity that we know isn't true. And the people who work on the technical side sometimes don't even realize that they ought to, that the bias can creep in and that these may not be representative. Jaya's example just with the fours is a perfect example of how you can't necessarily trust that the answer that it's giving you is 100% correct because it's an objective machine algorithm and so on. So in this case, if we have systems that are making and executing judgments autonomously to some degree, without a clear understanding of what can go wrong, and also without a clear mechanism for how to right that wrong if it does go wrong, right? And that's another issue, the whole gigantic sort of mess of responsibility, ethical and legal responsibility in such cases. Whereas in the olden days, you could put that police chief on trial if you thought that they'd been abusing and misusing their power and surveillance, for example. If it's a system that made a recommendation to a judge who just signs off on what the system's already said, it's not clear who's responsible for what's gone wrong if we deem after the fact that something went wrong. So I would say I don't disagree with you that there, in a sense, there's not a new problem. There are just new dimensions to it that are we need to figure out. We need to make sure everybody understands that they exist, at least, that these new dimensions, so that we can navigate them effectively.
And are definitely exacerbated by the speed problem, right? To be able to keep up with the speed of technological progress and regulate, you have to be able to understand what's going on. And if it's too fast, you can't reflect in the same way, even though some of the underlying mechanisms are exactly the same. I think this speed problem is really exacerbated by what the technology is enabling. Like emerging technology will always have these issues, and automation and the changing landscape of the workforce is always in play, right? It's not just losing jobs; you're creating new jobs as well, right? So there's so many dimensions to the problem to be able to, or the issues around the emerging technology that AI is enabling to keep track of, and it's too fast. Or maybe it's so fast that we haven't quite figured out how to frame it properly. So this is why, of course, education is a crucial dimension, and why there's such a thrust to be able to expose students as early as possible to these topics.
But the point that Professor Dent makes about which jobs are being replaced is fascinating. There's I think a delicious irony in the fact that AI systems are best at replacing jobs in spaces where there are very, very clear rules and very, very clear output as to if something works or not. And that almost defines programming itself. So there's something almost karmic about the fact that the industry that will largely industrialize these systems may suffer the largest job cuts at the bottom, obviously, of their field, because AI systems can code. So will we really need people to make websites anymore? I think Jaya mentioned this in another presentation, that AI systems will probably make websites in a blink of an eye. We won't need web developers anymore at some point.
Yeah, it is interesting. I mean, just to be clear, I'm not against examining the ethical dimensions and incorporating that into the AI program. I think that's great. I was just curious whether, I mean, a lot of the AI debate seems to suggest that there's some new ethical issues, and I was curious what your perspective was on that, because I've never been convinced that these issues are really new. I mean, AI is really, sophisticated, it's impressive, it's powerful, but ultimately it's just an algorithm like all the algorithms we've used before and subject to the same, you know, garbage in, garbage out issues. So anyway.
Emily,
Well, thanks.
Oh yeah, I was just going to add to the conversation that the reason I brought this up was not because, so yes, I think that the questions, the ethical questions that AI raises are specific and, you know, somewhat new. Like, you drill down to the specifics of any ethical question, and there's going to be some new dimension that isn't just like an ethical catch-all. Okay, fine. But I think the general question of, you know, are new technologies requiring ethics? Like, that is a long-standing problem. And this is why I was asking in the first place. The problem of like, we need to upskill people on the technical stuff without, you know, encouraging them to have conversations that, you know, ask the ethical questions and, you know, communicate in like integrative feedback loops with people who study the ethical questions. Like, I think that's a long-standing problem that tech fields have when putting forth new technology. I think, you know, the fact that AI cycles things quickly and then puts them on autopilot are the reason that we're raising this question so urgently in this field. But, you know, it's not a new problem that we have. We've always had this knowledge gap where people who are tech people kind of, so, you know, at worst they're just ignorant, or at best they're just ignorant of ethics, and at worst think they're above it.
Yeah, no, that's fair. Yeah.
So I just want to very quickly say, 100% agree. Techies like me need to be more aware of the ethical, or in general, all the impacts of what we're doing. But I think that we also, and I can speak as a computer scientist, we're also very like snobby, right? We don't invite people from the soft sciences into our domain. And that's a big problem because, you know, you can train us as much as you want, but unless we're open to listening to the opinions of the others. So that's why I think the kind of the two-pronged approach is the only way to go. We've got to get the social scientists into the conversation as well. I also wanted to say that I am very sure that my colleagues will really start pounding on the environmental impacts of AI as soon as our jobs are out. So just wait for that to happen, but that's happening.
Yeah. Thank you all. Very interesting conversation.
If I could add, I think if there were one, not a political scientist, is a social scientist that you'd want to talk to about this, it would be, like, I really love the work of Yochai Benkler. I don't know if you've ever heard of him, but this is exactly what he does. He just looks at the issues that come up with innovation, and he's been like tracking the history of innovation since like the invention of like the record player. And his work is absolutely fascinating. He's a professor of entrepreneurial legal studies. Anyway, well worth looking into. Yeah.
And if I may add to the recommendations, you know, in addition to Benkler, I mean, I'm not sure, Professor Dent, if you're a social scientist yourself or not, but a perhaps slightly less social scientist academic work would be 21 Lessons for the 21st Century by Yuval Harari. I mean, there's a fair number right now of well-known public intellectuals who are trying to explore these ethical issues and determine the extent to which these dimensions are new. And, you know, so it's worth asking the question at the very least, because, and that's a point I'd like to add to Emily's comment in the CEGEP system, because we evolved at Dawson College at CEGEP. I mean, one of the explicit mission is not only to create or form, educate technicians, but also citizens. So that's why they all have to take general education courses, including 3 compulsory humanities courses. And that's part of our job as humanities teachers, to raise these questions at the very least, so that we can help with the fostering of critical thought. So that's the idea. Even if we don't agree on exactly the different, the different ethical recommendations, the idea is at least to ask the question to make our students aware of these potential consequences of these fairly recent technologies. So again, I think that's part of our mission at Dawson College, to create citizens. So Yuval Harari, and in Quebec, by the way, there's Martin Gibert, who might be our leading expert on the ethics of algorithms. And again, you can find his work easily online. So there's a increasing number of public intellectuals addressing these questions, thankfully.
Okay, so it is now 11:15. So thank you so much for our lovely presenters. It was a very comprehensive discussion. And to our attendees, I'll remind you there is now a keynote presentation taking place. So if you're interested, please go check it out. And I'm going to close the session here. So thank you all.